So in this video, we will compare the energy bands of semiconductors, conductors and insulators. And we have seen that in the case of semiconductors, there is a gap between valence band and conduction band. Let's say this is our valence band and this is our conduction band. So there is a gap between valence band and conduction band, and we called it as energy gap. Now, in the case of silicon at 0 Kelvin, its value is about this many joules. So Eg equal to, there is this gap here between conduction band and valence band is this many joules. Now this joule is not a convenient unit when we talk about energy gaps. So you can see it's a really small number when represented in joules. So instead of joules, we use another unit and we call it as electron volts. Now it is equal to 1.16 electron volts. So electron volts makes it easier for comparing different semiconductor band gaps. Now the relation between electron volt and joule is really simple. That is 1 electron volt is equal to 1.6 into 10 power minus 19 joules. This number, you may be familiar with it. We have been mentioning it repeatedly during all these videos. So here we have electron volts. And this energy gap is a little bit dependent on the temperature, and its value changes to around 1.11 electron volt at around 300 Kelvin. It is good to remember the range of values in the case of silicon. So it is around 1.11 electron volt at 300 Kelvin, what we consider as room temperature in our discussions. Now we will compare the band gap of conductors, semiconductors and insulators. Now we have mentioned that metals are really good conductors and they have large number of free electrons and their conductivity is high. It is visible in their band structure. That means the valence band and conduction band do not have any energy gap in between. They either overlap, they can be considered as either overlapping, or they can be considered as there is no band gap at all. So even at 0 Kelvin, metals can conduct really well. In the semiconductors, we have a band gap between valence band and conduction band, but the gap is small. And we have seen that in the case of silicon, its value is around 1.16 electron volts at 300 Kelvin. Now let's see the case of insulators. You can see that the gap between valence band and conduction band is really large in the case of insulators. That is many times, say 5 to 10 times that of semiconductors. It's approximately between, its value ranges from 5 to 10 electron volt or more. So you can explain the conductivity of different materials in terms of its band gap also. So we have seen that in semiconductors the gap is small. In metals there is an overlapping. It can be considered as there is an overlap of valence band and conduction band, but in the case of insulator the gap is really large, and this is visible in the conductivity of this material. Metals have high conductivity. Semiconductors can be considered to have medium conductivity because conductivity is in between that of insulators and metals, and in the case of insulators the conductivity is really low. So we will be using electron volt as the preferable unit of energy, and 1 electron volt is equal to 1.6 into 10 power minus 90 joules. So the conversion from electron volt to joules is really easy. Let's say the value of energy gap is, let's say 1.5 electron volt. So in order to convert it into joules, all we need to do is multiply it with 1.6 into 10 power minus 19. So that is equal to 1.5 into, we have to multiply it with the value of Q, that is 1.6 into 10 power minus 19 joules. So that is equal to 2.4 into 10 power minus 19 joules. You can verify it here. Yeah. Yes, that is. So that is 1.5 electron volt equal to 2.4 into 10 power minus 19 joules.